working on test 3 review. Let's see. I want to do 14 through 20 with you this time. I've neglected to tell you where each problem came from, and I meant to do that. So number 7 comes from section 3.2. 8, 9, and 10 come from section 3.3. 11, 12, and 13 come from section 3.4. Need to do a little bit of, sort of cleaning up on 1, 4, and 7. Number 1, they're going to ask you the degree in addition to asking you, is it a polynomial function? So the degree is just the highest exponent. In that problem, there's the highest exponent, so the degree is 2. That's all. Number 4 is a little bit messier. Number 4, you've got zeros of 6 and -2. So they're going to ask you for that. You're going to put 6 and -2 in there. And then they're going to ask you for things like the largest number has how many, crosses the axis or touches, that kind of thing. Well, what they're referring to is these two numbers relative to each other. So the largest number, they're talking about the 6. When they talk about the smallest number, they're talking about the -2 because 6 is a larger number than -2. If you're having trouble understanding that, text me, call me, email me, and I'll help you with that. I'm not going to help you with the problem, but I'll help you understand what they're asking you for. Number 7, let's see. Number 7 asks you in there to find the y-intercept. Remember, that means anytime you see that word intercept, it means to zero out the other variable. So we're putting in a 0 for x. So in that equation, it would be 0 plus 1, 0 plus 3, 0 plus 5 squared. So f of 0 equals this mess. 0 plus 1 is 1, 0 plus 3 is 3, 0 plus 5 is 5, and we're going to square it. So 1 times 3 times 25 is 75. So the y-intercept is 75. That's all you need to worry about there. They're also going to ask you about, is there symmetry in this problem? Is there y-axis symmetry? Is there x-axis symmetry? Is there neither? So you're going to look at it, and this is what we had before. Y-axis symmetry means if you use this as a mirror, do you see the same thing to the left as to the right? Well, heck no, this is busy on the left-hand side. There's nothing going on the almost nothing going on the right-hand side. X-axis symmetry, this is the mirror. The x-axis is the mirror. Is there the same thing on top as on bottom? And of course not. So that's just an eyeball look. So this one would be a neither answer for symmetry. Okay, let's go ahead and get started on number 14. Let's see, let me move my little sheet up. Okay, and let me see where I can go to. Okay, got that. Okay, number 14 is asking you to find a rational zero and use it to find all the zeros of the function. So on number 14, let's see, equals x to the third minus 4x squared plus 2x plus 4. Okay, if we're looking at the zeros, we can tell they're going to be plus or minus 1, plus or minus 2, and plus or minus 4 are our possibles, because this is a 4. Those are all the factors of 4. And we've got a 1 in front, so the denominator's a 1. That doesn't change anything. So let's just grab any of the numbers. I'm going to grab 2. Put in 1, -4, 2, 4, and see if this will give me a remainder of 0. 1 times 2 is 2. -2 times 2 is -4. -2 times 2 is -4. That zeroes out. So that tells me that 2 is a rational zero. That's good. What we've got left here is x squared minus 2x minus 2, and we're trying to factor that. The signs need to be different. We're looking for two numbers that multiply to give us 2, whose difference is 2. Nothing like that exists. So that means we would have to do the quadratic equation. But the problem you're going to have is going to ask you to find the real zeros. So 2 is a real zero. These guys are going to be, not real. They're going to ask you for rational zeros. So 2 is a rational number. You can make 2 over 1, and there it's a ratio. It's on the number line easily. These two will be on the number line, but remember, we're going to have negative b plus or minus and then a square root happening here. So those are irrationals, and they don't care about those in this problem. So you're functionally done. Once you have found all of the rational zeros, you're done. So 2 is an answer. This we just sort of give up on because they only asked for rational. On your number 14, they're only asking for rational zeros. All right, number 15, putting it all together, they tell you that we've got 3 different zeros. So let me set that up. 3 is one of them, so x minus 3, you know that's always a liar when it has the x attached. And I is a 0, and you know, so that means x minus I. But if any non-real number is an answer, so is its conjugate. So those are our 3 right there. What we know is that f of x will equal some number in front there. We don't know what that number is in front there, but we have some information about it. They're telling us that f of 2 will give us 20. So let's hold on to that for just a minute. Let's go ahead and FOIL these two out. X times x is x squared. Outside and inside cancel out. And then the last is negative I squared. Remember, I squared is a negative 1, and then we multiply these two. So we have x squared plus 1 happening there. Bring in the x minus 3. And then we've got this a equals f of x. Well, f of 2 is 20. So let's substitute f of 2 equals this mess. And then we know that f of 2 is 20. So take that out, 20. So what that means is if we plug in a 2 for these x's, we'll get a 20 over here. So 20 equals a, let's plug in a 2. Plug in a 2. 2 minus 3 is a negative 1. 2 squared is 4. 4 plus 1 is 5. So we get 20 equals a times negative 5. Divide both sides by negative 5. And we get a equals negative 4. So that's what we want to do. Back up, way back up to the top. Way back up here is what we're going to use. So they want you to say f of x equals, let me make sure we're still on the screen. Sure we are. F of x equals negative 4. Put this negative 4 in place of the a. And then x minus 3, x minus I, x plus I. That's what they're looking for the answer for number 15. Okay, number 16, they're asking for the domain. Domain is talking about what you're allowed to use for x. So in this case, we have a denominator, and that's a problem. If you've got a denominator, you have to be careful that it does not equal 0. So let's set it equal to 0 and create the problem. Let's see where the problem lies. Is there GCF? Yeah, both terms have an x. And there we go, we found our two zeros. X is a 0, and x minus 4 is a 0, which gives us x equals 4. Okay, remember, these are not good answers. They're bad answers. They're what creates the 0 here in the denominator, and anybody divided by 0 is against the rules. So the answer here, they're going to supply you with the set of all x such that x cannot equal, and you'll be putting in 0 and 4. That's the part you'll be putting in right there. Okay, I think I'll quit on this page. Let me go grab another page. You just plan your weekend as if. Let's see. Okay, get some tape on this. Whoops. This is how it goes. Make sure you can see that. Yeah, that's good enough. Let's see, we have done number 14. Number 14 comes from section 3.4. Number 15 kind of comes from 3.4 and 3.5. Number 16 comes from section 3.5. Okay, all the others come from section 3.5, so 17 through 20, because sounds like I'm going to forget to tell you. Number 17, we're looking for vertical asymptotes. Vertical asymptotes on a graph are going to look like that sort of line, where the graph won't go. Maybe the graph will look like that, like that, like that, something like that. So these are the vertical asymptotes about which, or through which, across which, our graph is not going to cross. Our graph is not going to go. So vertical asymptotes, for that you look at the denominator. So on number 17, we've got x over x squared minus 25. To find the vertical asymptotes, set the denominator equal to 0 and factor. This will factor into x plus 5, x minus 5. So remember, these are liars. So we'll have one vertical asymptote at x equals negative 5. We'll have one vertical asymptote at x equals positive 5. So if you were asked to draw it, and you're not being asked to draw it, but you would go out here to positive 5 and negative 5. 1, 2, 3, 4, 5. Right there, you have a vertical asymptote. Right there, you have a vertical asymptote. So your lines would never cross there. Any drawing you're doing, any function you've got would not cross across those. Those are borders, those are walls. In that particular question, when you go to take your test, they're going to ask you about holes. You won't have any holes to worry about. I picked questions that didn't have holes, so no worries on holes. Just ignore that completely. Number 18 is asking you for horizontal asymptotes. Remember, those will go sideways. Those are horizontal asymptotes. So in a graph, a horizontal asymptote is going to look like, let's see, let me look at our problem. Yeah, like there's a horizontal asymptote. So the graph would never cut across that line. It might do something like that, who knows, but it wouldn't cross that asymptote line. So what do we got going here? In this problem, you've got f of x equals 8x over 8x plus 8. There are three rules. In this case, let's look at this case. In this case, the degree of the top equals the degree of the bottom. x to the first, x to the first. They're equal to each other. What that tells you whenever they're equal to each other is that your line, your asymptote line, will be equal to the leading coefficient of the top divided by the leading coefficient of the bottom. So in this case, the leading coefficient of the top is 8. The leading coefficient of the bottom is 8. So our horizontal asymptote is y equals 1. So y equals 1 is your answer. I want to remind you, let me see where I am on this piece of paper. Let's see, I can go down to not very much further. Okay. So if you were doing a problem where the top was less than the bottom, the degree of the top was less than the bottom, for instance, 8x over 8x squared, where the degree of the top is smaller than the degree of the bottom, then in that case, the horizontal asymptote is y equals 0. The third case we could have is that the top is greater than the bottom. For instance, 8x squared over 8x. And in that case, you have no horizontal asymptote. None at all. So those are the three cases you could have with horizontal asymptotes. Oh, and then the one that we did, y equals 1, would look like this. The example I showed you is like what we were doing. Let's finish this up. Number 19, you're going to be starting off with this as you're asked to graph this. You're going to match this to a graph. So let me grab my little board again. You know that the graph of 1 over x, the graph of 1 over x, oh dang it. Simple 1 over x graph does something like that. And the other end does something like that, okay? That goes through 1, 1, goes through negative 1, negative 1. Kind of important, those two pieces. Okay, our new graph, we're using this as our basis. This is the graph of 1 over x. What we're going to do now is graph 1 over x minus 5 plus 3. So what you need to notice here is that in the original, it's got the vertical asymptote and the horizontal asymptote. That where the two asymptotes cross is at 0, 0 for the basic graph, or the parent graph. We're going to move that. Ours right here, let's see. Ours right here, the asymptote vertex, if that's such a thing, is at 5, 3. So let me go find that on the graph. Remember, it's the opposite of this one, the same as that one. The first number is the opposite of what you see. It's attached to the x piece, and then the same as what sits there. So our asymptote crossing is going to be at 5, 3. So go out 5 and up 3. There's the vertical asymptote for this. Here's the horizontal asymptote for that. And we're just shifting our little boomerang pieces right there. And through there, something like that. So these two red ones are the parent. They're going to shift over 5 and up 3. And that's what we're doing with number 19. You're matching on that one, and that's it. Number 20, new problem. The problem that is listed on your practice sheet, your review sheet that you might have pulled offline, is not the one I'm using for your test. The new problem for this one, let's transform something like that. Let's transform the x squared graph. So let me remind you of what the simple x squared graph looks like. Simple x squared has the same sort of thing happening, except this guy flips up. And that's in your notes. So it's got a horizontal asymptote of the x-axis and a vertical asymptote of the y-axis. What we're trying to do with number 20 is we're going to have to look again for the asymptote vertex. The opposite of what sits between the x and the exponent. There's no number there, so the x coordinate of the asymptote vertex will be a 0, and then the same as that. So 0, 2 is our new asymptote vertex. So let's see, 0, 2, 0 says don't go sideways, 2 says go up. So that's where the two are going to meet. Let me see, let me find a blue marker here. So the vertical will stay the same. The horizontal will move up. And so that's the crossing for these two boomerangs. So the two boomerangs will look like that. Notice it goes through the over one, up one from there. And this one does the same sort of thing, doing that kind of thing. So the blue is the parent graph shifted up to. Okay, so this is more like your 20 will be. And I told you all of 17 through 20 come from 3.5. And I think that's about it. I will post the test on what day? We'll talk about it on Tuesday in our virtual class. And I will see you next time.